Welcome to the class. In this class, we will discuss the questions based on a train with the help of this example. But before going for this example, let's brush up our concepts of this topic. This topic is basically a topic of relative speed, for which the main formula I have written here. That means if there are two objects and the objects are moving in or in same direction or they are approaching towards each other, then we can say that time taken by two objects of lengths LA and LB and speeds SA and SB to cross one another is equal to LA plus LB, that is their lengths combined, divided by the relative speed. So in the numerator, as we know that the time is basically time is equal to distance by time. So distance here is the length of the two objects combined, LA plus LB, distance over speed, and the speed in this case will be the relative speed. If the objects are going in same direction, then we will apply the negative sign, because in that case the relative speed will be the difference of the speed of these two objects. But in case the objects are approaching towards each other, that is they are coming from opposite direction, then the relative speed will be SA plus SB. That means the speed will be combined. So this is the basic formula. On the basis of this basic formula, I have written formula for certain specific cases. We will discuss it one by one. Like time taken by train of length LA and speed SA to cross a pole. That means there is a train of length LA and speed SA, and if the train has to cross a pole, since the pole is stationary, so applying this formula in the numerator, the length of LA, that means length of the train, plus LB, since the second object, that is the pole, has no length, so that means LB equals 0. So LA divided by, in the denominator, SA, that is the speed of the train. Again, because here the pole has no speed, that is SB equal to 0. This is the first case. For second case, if the train has to cross a platform of length LP, again the platform is also stationary but having certain length. So in the numerator it will be LA plus LP, length of train plus length of platform, divided by only the speed of train, because platform is stationary. This is second case. The third case is that a man is moving with a speed SM in the same direction. Again, when the man is moving, then for man, the length of man is 0, negligible as compared to the length of train, but the man has a speed of SM. So in the numerator of this formula, it will be LA, because LB is 0, divided by SA minus SM. Why? Because the man is moving in the same direction of the train, that's why SA minus SM. Okay, for fourth case, a man moving with speed SM in opposite direction. Okay, if the man is moving in opposite direction, then the case will be similar to the previous one, but the difference will be in the denominator we will have SA plus SM, because when two objects are moving in opposite direction, then their speed will be combined. For fifth case, the previous train is crossing a train of, that is another train of length LB and speed SB moving in the same direction. So applying this formula, the numerator will be LA plus LB, okay, divided by, since the trains are moving in the same direction, in the denominator SA minus SB. Here we have assumed that the speed of the other train SB is less than SA, that's why here SA minus SB. Otherwise in the denominator it should be the difference of SA and SB. Okay, going for the last case, sixth case. the first train is crossing another train of length LB and speed SP coming from opposite direction. It is similar to the previous case. The difference is that in this case both this train is coming from the opposite direction. That means both trains are approaching each other. So the numerator will be LA plus LB divided by SA plus SB, since they are approaching towards each other. So these are the different cases for which this basic formula has been applied. Now we will solve this particular question. First, read the question. A train of length 500 meter is running with a speed of 36 km an hour. Calculate the time taken by the train to cross. First, a pole, in case A, in case B, a platform of length 500 meter. C, a man moving with a speed of 18 km an hour in the same direction of the train. And D, another train with the same speed and same length coming from opposite direction. So first thing what we'll do is that since the length of the train or length of the platform, these are actually given in meter, and the speed of train is given in kilometer an hour. So first of all we have to make the units same. So we know that the speed of train let's call it the first train, whatever SA, that is 36 kilometer an hour. We have to convert this 36 kilometer an hour to meter per second. So we will multiply it by 5 by 18. If you multiply this by 5 by 18, it will be converted to meter per second. So 18 to the 36. So it is basically 2 into 5, that is 10 meter per second. Okay, now we can solve the individual cases. The case A is this train has to cross a pole. We will apply this formula. Okay, time taken to cross a pole, that is in case A, is equal to LA, that is mean speed of this length of this train, that is 500 meter, divided by the speed of train which we have seen here, 10 meter per second, by 10, that is 50 second. Answer to the question A is 50 second. Okay, part B, a platform of length 500 meter. We will apply this formula. For this, the time taken to cross platform, right, in this manner, is equal to the length of train plus length of platform that we have seen. Length of train is 500 meter, it is given. Length of platform is also 500 meter, divided by only the speed of train. Why? Because platform is a stationary object. Again, the length of train we have calculated above is 10 meter per second. So it is 1000 by 10, that is 100 second. This is answer to the second question. Okay, for third, a man moving with a speed 18 km an hour in the same direction of the train. So first of all, the speed of man has to be converted into meter per second. So 18 km per hour is 18 into 5 by 18, that will be 5 meter per second. We will apply this formula. A man moving with a speed of 18 km per hour in the same direction. A man moving with a speed of some speed in the same direction. So this time will be equal to length of train. Why? Because this length of man is 0. Length of train we have seen is 500 divided by, since they are moving in same direction, it will be the difference of their speeds. The speed of train is 10 meter per second minus speed of man is 5 meter per second, that is 500 by 5, that is again 100 second. So this is the answer to the question number C. Then for G, the part D, another train, if the previous train has to cross another train with the same speed and in same length coming from opposite direction. That direction is important. Since length and speed of the other train is also the same as the previous one, we can calculate time to cross in the case D will be equal to, it is coming from opposite direction, so we will apply this particular formula of this case. It will be length of both these two trains combined, that will be first one 500 plus 500 because length is same for both of the trains, divided by, since they are moving in opposite direction, their speed will be added. That means 10 plus 10 because the speed of both the trains are same, so that is 1000 divided by 20, so that is basically 50 second. That is the answer to this question. So we have seen that in case of trains there is a basic formula which is applied to different cases. We will see more example in the next classes.